Hello. So this is the calculating heat transfer or Q question walkthrough. The formula is here. It's also found on table T of the reference table. So Q stands for heat, as you can see on table T. M stands for mass. C is the specific heat, and delta T is the change in temperature. Delta T is equal to the change in temperature. So final temperature minus initial temperature. Okay, that's also important to know. Specific heats are a constant. If it's water, you're going to find it on reference table B. Table B for water. And if it's not water, it'll be provided in the question. So make sure you have your calculator. Okay, here we go. A sample of 305.2 grams of water is heated using a Bunsen burner. The water's temperature changes from 23.7 degrees Celsius to 46.0 degrees Celsius. Calculate the amount of heat energy or Q transferred, and then it asks, is it exothermic or endothermic? So I forgot, I was nice. I provided it to you here, but you do indeed need to know that it's also on table B. So we are solving for Q. So Q equals mass 305.2. Mass Q equals M. C is 4.18, and I'm not going to worry about the units just yet. And T final, which is 46.0, minus T initial, 23.7. So remember, order of operations, we should take care of that first. 46.0 minus 23.7 is 22.3. Okay, so now we need to multiply those three things together. 305.2 times 4.18 times 22.3. And you get 28,448.9. Now let's talk sig figs. Our largest number of, we want the smallest number of sig figs. Looks like that's 3. So round that to 3 sig figs would be 284. Hold your zeros, 00 joules. Okay. If it doesn't tell you to round to sig figs, you can just round to something appropriate. Okay. Why won't this let me go? All right. A blacksmith is working with 4,500 grams of heated iron. After he molds it, he allows it to cool, and 608,291 joules of heat energy is released. Calculate temperature change. So see how we provided the specific heat of iron. So we're looking for temperature change, which is delta T this time, not Q. So heat is released. That's a negative Q. 608,291 Q. Mass is 4,500. Specific heat is 46, and we don't know. So then we just need to do some algebra. So 4,500 times 0.46 is 2070 times delta T equals that same thing. Divide both sides by 2070. 2070. And yes, you will get a negative number, and that's okay. It just means that heat is given off. So 608,291 divided by 2070. Now let's talk sig figs. Looks like we've got 4 in the first, 6, because we're not going to take them from our specific heat that's a given there. So we want 4 sig figs, which would be 293.9 degrees Celsius. And you could say negative because it's T final minus T initial. So that just means 293.9 degrees Celsius is given off. And I'm sorry, this is not the best stylus, but it's going to do for today. All right. Aluminum can is heated. The temperature rises from 25 degrees Celsius to 85.3 degrees Celsius, gaining 30,000 joules of heat. What is the mass? Notice I provided you the specific heat of aluminum. So we have 30,000 decimal place. Okay, so that's our 5 sig figs. M that's what we're looking for. C is 0.90 because it's not water, it's aluminum. T final minus T initial, so that's 85.3 minus 25.0 gives me 60.3. I just did that subtraction on my calculator. I didn't show you. So then 60.3 times 0.90 gives me 54.27 times our variable, still equal to the 30,000, divided both sides by 54.27, 54.27. So 30,000 divided by 54.27. And so we want 3 sig figs from the temperature. So I'll change color. So it's going to be 553. And that's mass, so it's grams. The calculator told me, oh, that's a G, goodness gracious. The calculator told me 552.79, so that's why we're rounding it to 3 sig figs. Here we go. A Trane's steam engine produces 576 grams of steam. The steam leaves the boiler at 208 degrees Celsius, but quickly cools to 97.5. Calculate the amount of heat transferred. Is it X? Oh, I forgot. Let me go back for a second. That first question, is it endothermic or exothermic? Well, seeing how it's a positive Q, this means endothermic. Negative Q would be an exothermic. All right, so back to this one. So we are solving for Q again. M, 976. C is 1.7. Notice water vapor is a little bit different than regular water, liquid water. T final is 97.5 minus 208. So it gives us negative 110.5. That's fine that it's negative. Multiply those three together, times 1.7 times 976. And Q is, now let's talk about sig figs. Looks like we need 3 sig figs because we're not going to take it from the water vapor specific heat. That's unknown. So I have 183341.6, and it's negative. Keep that. So if I want 3 sig figs, 183, because that 3 doesn't round it up, 000. And this is joules. Now, seeing as this is a negative number, that tells me that it is exothermic. Okay? And it also said released or cools. So that's another way that you can help figure it out. Temperature outside changes from 0 degrees Celsius to 37.8, 11.2 grams of mercury, gains such and such. So we're looking for a specific heat now. So we don't need to look for it. That's what we're solving for. It's not going to be given to us in the problem. M, here's our C, delta T. So it goes from 37.8 to 0. So actually, it's the other way around. It goes from 0 to 37.8. So T final minus T initial is 37.8. All right. So we're going to do 11.2 times 37.8, and we get 423.36 times our variable, C, equals blah, blah, blah. Divide both sides by 423.36. So 43.8 divided by 423.36. So let's do that. 43.8 divided by 423.36. Okay, let's talk sig figs. Looks like we're going to go with 3 sig figs because 0 doesn't have sig figs. So 3 sig figs, so 103. And this is specific heat, so that's joules per grams times degrees Celsius. I'll put that in a different color so you can see that that is our answer. All right. A 50-gram sample of silver is heated so it can be molded into a pair of silver earrings. Silver is heated from 37.7 degrees Celsius until it melts, and 110,333 joules of heat energy is gained. Calculate final temperature, and they give us the specific heat of that. So remember that T final minus T initial is delta T. So we're going to have to substitute this equation in. So 10,333 equals Q equals M 50 times C, which is 0.24, delta T. Our final temperature is what we don't know. Our initial temperature is 37. That's a 3. Goodness gracious. 0.7. All right, so 50 times 0.24 is 12 times the quantity TF minus 37.7. This is just algebra. Equals that number. Divide both sides by 12. This is gone. 10,333 divided by 12 is 861.08 blah 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 and change. We're going to need to add 37.7 on both sides in order to get rid of that and leave us with TF, so plus 37.7. All right, so now we need to look for sig figs. It looks like we've got 3 sig figs in our mass, and then we have 3 sig figs in our temperature and 5 in the Q. So we want 3 sig figs, which would be 899 degrees Celsius. That's hot. It's really hot. Okay, I hope this helped. If it did not, please reach out. Thanks.